why you need this Node MCU board other than other boards like Arduino board, all those boards are there. Instead of using those boards, why you are using Node MCU board? Okay, all those things we'll be seeing now. Before starting, okay, so I will show you some sensors. Okay, I will show you some sensors. Can you see this sensor? Can anyone answer? Shamal madam, can you see this sensor?
Yes, sir, we can see.
Okay,
yes.
So this is humidity sensor. This is humidity sensor. Okay, if you are using this sensor as it is, okay, if you are using this sensor as it is, we cannot, okay, so only thing is we will get some output voltage value, If you want to send this output voltage of the sensor to internet, in between we need some platform. So that platform may be your Arduino board, or maybe your Node MCU board, or maybe your Raspberry Pi board. Okay, so why you need this one? So we need to analyze the sensor data. Sensor data may be, okay, it is humidity data or light intensity data, okay, or some temperature data or some air pollution data. Okay, so I have shown some, okay, humidity sensor. Okay, so similarly you are having some temperature sensor. This is temperature sensor. So like that you are having different sensors. If you are using sensor individually, what you can do is you will get some voltage. But if you want to transfer this signal, that means whatever voltage that you are getting as an output from your sensor, if you want to transfer this voltage to internet, okay, if you want to transfer this voltage to internet, or if you want to control some device using either Bluetooth or using Wi-Fi or using web page, compulsorily in between you need to have some platform like microcontroller and Wi-Fi module, all those things. So now why I am selecting this Arduino board means Arduino board is having, okay, microcontroller, inbuilt Wi-Fi module.
Sir, we are not able to see we are not able to see any of the screens, sir, and sensors.
Sensors you are not able to see. 1 minute, I will show you.
Slide only is there, sir. Actually, it is for streaming.
You have to see my picture. So my video is there, no? So there you have to see the sensor. There you will be.
Yeah.
So is it visible, this sensor? 1 minute.
No, sir.
Actually, wherever my, okay, video is there, no? There you see. So there you can see the sensor. Can you see it?
Yes, sir.
Okay. Just for your understanding sake, I have shown that sensor. So now, all of you, please mute yourself. It is a disturbing. Okay, it is disturbing me. Okay. So now, why you need this Node MCU board means you need to transfer the sensor data to. Okay, you need to control. Okay, this you need to collect the sensor data and you need to publish in some cloud. Okay, so if you want to do that one, compulsorily you should have some microcontroller and you should have some internet facility like Wi-Fi or Ethernet. So that facility should be there. So all those things like this Node MCU is having, okay. So you just see here, Node MCU is having Wi-Fi module. This is your Wi-Fi module, okay, and it is having inbuilt microcontroller. Okay, so and it is having one analog pin. So that means only one analog. Okay, suppose if you are using some moisture sensor, only one moisture sensor you can connect to this Node MCU. So if you are having more number of analog inputs, so for that more number of analog inputs, this Node MCU is not suitable. Okay, if you are having only one analog input, in that condition, this Node MCU is useful. And you just see here, here 13 digital input output pins are available in Node MCU. 13 digital input output pins are available in Node MCU board. Okay, and you are having one. So you just see here, these are the different pins. These are different pins on this PPT. I am showing pointer. You just see here, these are different pins. Out of these pins, you are having only one analog pin and 13 digital pins you are having, and this is your micro power cable. So through this we can debug the code. So if you want to debug the code, you can debug, or if you want to dump the code from your laptop to Node MCU, you can do that using this particular micro power cable. So here you are having micro power cable. So side side by that micro power cable, you are having two buttons. One button is for resetting, another one is for flashing. Okay, this is for flash, this is for reset. So you are having two buttons like that. Okay, so this is your antenna, and you are having, so this is your Wi-Fi module, and under that Wi-Fi module you will be having microcontroller. So now what is our requirement? If you want to transfer the sensor data to some sensor data to some cloud, or if you want to control if you want to control some light, fan, or something like that based on the sensor data, so compulsorily you should have microcontroller and you should have some Wi-Fi module. So all those facilities are available in this particular Node MCU board. That's why I am selecting this Node MCU board. Okay, so and one more thing is this Node MCU board, you just see here. So these are the digital pins. Okay, GPIO 16, 5, 4, 0. Okay, generally in program you will be mentioning this pin number. If it is pin number 2 means actually, so it is connected to D4. It is connected to D4. In program we will be writing pin 2. Pin 2 means, so actually that is connected to D4. D4 of your kit. So these GPIO pins are internals. Okay, internals. GPIO 2 means that is pin 2. Pin 2 is connected to actually which one? Digital pin D4. Okay, so you are having some power cable, power supply 3.3 volts power supply, two 3.3 volts power supplies are there, and you are having ground. Okay, is it clear now? You just see here only one analog pin is there. So 13 digital pins are available. Okay, only one analog pin and 13 digital pins are there in this particular Node MCU board. Okay, 13 digital pins are available in this particular Node MCU board. Okay, is it clear? Any doubt till now? So next thing is Arduino IDE to program. So suppose, so now what you have to do, you need to write a code in some platform. So you need to have some IDE where you are writing your code, and after writing code you need to compile it. Okay, you need to compile it. This Node MCU board works for both C++ as well as for MicroPython. Okay, today I will show you some examples of C++ using Arduino IDE, some examples using MicroPython examples using some Tony software, UPyCraft. I will show you both the things. Okay, practical examples I will show you after completing this PPT. So I will take around 20 to 30 minutes for this presentation. After that, I will show you kits. Okay, I will show you program. After that, how to dump that program and how to see the output. All those things I will tell you. Now, what is the importance of this Arduino IDE? Arduino IDE is a freely available thing. Okay, Arduino IDE is freely available. So no need to purchase anything. Okay, so all the libraries which are required for this particular, suppose if you want to do some temperature, if you want to collect temperature using temperature sensor, so in that case you need to have library of that temperature sensor. All those libraries are also available freely in this particular Arduino IDE. All those libraries are also available. Okay, so no price for intellectual property. Okay, so number of well-wishers are there. If you are good in developing some library, you can develop some library, you can also contribute to this particular thing. Okay, freely you can use all these particular things. How to download this Arduino IDE, after that how to program it, I will show you step by step. Okay. Okay. So before this Arduino, like Node MCU, there are so many boards are there. Arduino Uno board, okay, Arduino Nano, Arduino Mega, Arduino. So these things are available. So why I am not choosing this particular boards means, okay. So here, okay, only microcontroller is available here. So you are not having any, okay, we are not having any Wi-Fi module here. If you want to connect our data to either cloud, or if you want to control using some app or using some web page, compulsorily you need to have some internet connectivity. Those facilities are not available on this particular thing, on these boards. That's why we are not, okay, we are moving on to, okay, Node MCU. Next one is, okay, so instead of using Node MCU, you can use Arduino IDE external Wi-Fi module. You just see here ESP8266 is external Wi-Fi module. Okay, so you connect your Wi-Fi module to Node MCU like this. Okay, power thing to these two things should be connected to power, ground pin should be connected to ground, and transmitter pin should be connected to some digital pin of your Arduino. Okay, Arduino Uno board. So you can connect like this. After connecting, now you open Arduino IDE. There you write a code and you dump that code into this particular Arduino. So now what you can do using this Wi-Fi module, you can transfer the sensor data to internet, or by using some, okay, app or any other thing, you can control some devices. Okay, here if you are using Arduino, here you are having six analog inputs, but only one analog input. But whereas in case of, okay, Arduino, you are having six analog inputs. If you want to send, okay, if you want to connect more number of analog sensors, in that case you need to use this particular Arduino board, or some new board like ESP32 board is also available in market now. Newly it is coming. You can use that board also. So there also you are having more number of analog inputs. So if you are using Arduino Uno board, compulsorily you should use this particular ESP8266 Wi-Fi module. You need to use this Wi-Fi module. And when you are connecting, so you just remember that this Wi-Fi module supports only 3.3 volts. You should not connect this Wi-Fi module to 5 volts. It supports only 3.3 volts. Okay, it supports only 3.3 volts. Okay, so next, moving on to next thing. Okay, necessary steps for installation of, okay, installation of this one. What you have to do, you just open Arduino IDE first. After that, open this Arduino IDE. How to start programming and all, I will show you after that. Okay, first you open Arduino IDE, go to preferences, and after that, in that preferences, what you have to do is, whatever link that is showing here. So in this PPT, whatever link I am showing, you need to copy this link in that particular preferences. Okay, some place will be there. Then there you need to copy this one. If you are copying this one and if you are okaying, so what is the advantage of this one means, instead of downloading library files separately and, okay, adding those libraries to your Arduino IDE, so directly you can, if you are using this link, directly you can open Arduino IDE, directly you can download library files and boards from that particular Arduino IDE itself. No need to download, okay, from, okay, Google or some other thing. Directly you can download these things using your Arduino IDE itself. Okay, no need to go for internet. Okay, so directly you can use this particular link, if you are copying this particular link in your preferences, okay, so directly you can download all the necessary things. Like if you want to download Node MCU board, so you can download. If you want to download some library files which are okay required for your Node MCU board, so those things also you can download without going to internet. From Arduino IDE itself you can download. So you just see here, I will show you this one practically. Okay, I will show you this one practically. Next, after this one, important functions of Arduino, okay, for minimal programming. So if you are just opening your Arduino IDE, so initially, so there you will be seeing these two things. One is setup, another one is loop. This setup is for void setup and void loop. Void setup, what for you are using this one? This is for initializing. Okay, this is for initializing. Void setup is for initializing, and this is for so running the function, whatever logic you are writing. Okay, so that according to that logic, so your okay kit will function. So this is here you will be writing your logic. Here what you are doing, you are declaring your input output pins, you are initializing all those things. In setup you are doing initialization thing, in loop you are writing your logic. Next one is, you just see here one example program. One example program is, okay, initially what I am doing, int LED pin, second pin of, okay, LED pin 2 means, okay, so pin 2, this is internal pin. Okay, now what you are doing, void setup, in that what you are doing, I am just initializing pin as output pin. You just see here, pin mode, LED pin, I am initializing this LED pin as output pin. I have done that initialization part. After that, what I have to do, I have to close this setup. Next, what I have to do, I need to write a logic here. Okay, what I am doing, digital write, I am writing, okay, I am just by writing this particular digital pin, what I am doing, I am making this LED pin high. So this pin should be high for, okay, so this many seconds, okay, so milliseconds, this 1000 milliseconds, it should be in on condition for 1000 milliseconds. After that, what I am doing, so digital write LED pin low, I am setting that LED pin off. So this pin will be in off condition for 1000 milliseconds. So like that we need to write a code. Okay, like that we need to write a code. So when we are opening this particular Arduino IDE practically, then you will be understanding this one. So next you just see here, this is a LDR sensor. Now you just see here, input device is connected at 4. Device is connected at GPIO 4. Okay, so this 4 is representing GPIO 4. Now, so this LDR is nothing but analog sensor. This analog sensor is connected to analog pin of your node MCU. Analog pin means A0. A0 means that is 0th thing. So A0 pin, ADC 0. Okay, so A0 means that is ADC 0 pin. After that, what you are doing, device pin mode. Pin mode, I am declaring it as output. This device, this pin, I am declaring it as output. So now what I am doing, I am sensing this particular LDR value. Okay, this analog pin is what it is doing, it is reading the okay LDR value. Based on this LDR value, what I am doing, I am controlling some device which is connected at digital pin 4, which is connected at digital pin 4. My LDR is connected at digital analog pin 0. So what it is doing, it is sensing the light intensity value. Based on this light intensity, I am just okay switching on and off, okay, some device. You just see here, if the light intensity is greater than 500, okay, so digital write, okay, digital write high. So what I am doing, I am making this particular okay 4th pin high. Okay, if this particular LDR data is less than 500, what I am doing, I am making this 4th pin low. So like that I need to write a code. Okay, so next I will show you some examples. Okay, out of these examples, few things we will see practically. So now you just see here, I am having my Node MCU board. This is my Bluetooth module. This is my Bluetooth module, and I am having some Android app. So now what I am doing, I am connecting this VCC pin of this particular Bluetooth module to 3.3 volts. VCC means power supply, and I am connecting this ground pin of this particular thing to ground. Next, what I am doing, I am connecting transmitter pin of this particular Bluetooth module to receiver pin, receiver pin of this particular Node MCU board, and similarly receiver pin of this particular Bluetooth module to transmitter pin of this particular thing. Now what you have to do, you just open your Arduino IDE, write a code, and you dump that code into this particular Node MCU board. After dumping that code into Node MCU board, so immediately you can open this particular app, and you can control these particular things. If you press red LED, so automatically to the digital pins, whatever, so you are having different digital pins now. If you are clicking red LED, so somewhere you just consider GPIO 10th pin is connected with red LED, so that red LED will be in on condition. So like that, using your Bluetooth module and your Android app, you can control some devices. Next one is using Wi-Fi module. Instead of using Bluetooth module, what I have done, I have used Wi-Fi module. So here also what I am doing, I am connecting some LEDs to some digital pins. So here for demonstration purpose, I am connecting LEDs. So if you want to use in real time, what you can do, in place of that LEDs, you connect some relays. So now if you click on this red LED on, so corresponding relay will be in on condition. So that relay is connected to some AC device. Whatever AC device is available, so that AC relay is connected to that AC device. So immediately if you are clicking on this particular red LED on, so that device will be coming to on condition. If you clicking on that particular red LED off, that device will be coming to off condition. I will show you this one practically, Wi-Fi and web page based control. I will show you these two things practically. You just see here. Next one is device control using web app. So device control using web app means what I am doing. So I am just opening Arduino IDE. There I am writing a code. So after running code, I am getting some IP address. You just copy that IP address, paste in some browser, Google Chrome or some other Mozilla Firefox, place there, and if you click on that one, so you will be getting this type of page. Now what you can do, if you are clicking on this particular on button, so automatically your LED is coming to on condition. If you are clicking on this particular off button, so automatically that LED is coming to off condition. You can see that those things live. So which is in on condition, which is in off condition, all those things you can see here. You can see here. So up to now whatever we have seen, so these are C programming based. Next one more thing is send sensor data to cloud. So you are having so many cloud platforms. UB dots, next ThinkSpeak. So like that you are having so many cloud platforms. So what you are doing here, so many cloud platforms you are having. Now what you are doing here, I am just reading the sensor data, LDR data. I am publishing this particular, I am sending this LDR data to cloud. I am sending that LDR data to cloud. In cloud platform, you can see all those data here like this. How to do that? I will show you. Practically, I will show you how to read that sensor data and how to publish that sensor data in cloud. So practically, I will show you. So up to this, you are doing with C++ programming. After that, Node MCU programming using MicroPython. So what is this MicroPython? C++ programming means what you have to do? Compulsorily you need to compile first. You need to compile. After that you need to upload this code into your Node MCU board. But if you are using Python, no need, like directly, okay, directly you can run, okay, it is acting like an interpreter. Okay, if you just type the code and if you run, if the code is correct, so automatically you will get an output. No need to compile, and after that no need to upload. So that is the advantage of using MicroPython. So nowadays what is happening, why I am explaining about this MicroPython means, nowadays so many people are, okay, they don't know C++ language, but they know Python language. They know Python language. So Python is a little bit easy compared to your C++. Okay, so most of the people are aware of this Python. So that's why I'm explaining about this Python also. I'm just throwing some light on this Python also, how you can, okay, write a Python code and how you can control the device using this Python code. So those things also I'm showing. Okay, so what is a installation of MicroPython on hardware? So these are the things that we are going to see. So you just see here. So MicroPython means, what is the difference between Python and MicroPython means? So for like in Python, what are all the library files that are there? It won't support all the library files. This Node MCU board, it will support only few library files. That's why I'm calling it as a MicroPython. If you want to use Python directly, you can shift to Raspberry Pi board. Okay, you can shift to Raspberry Pi board. Okay, so this MicroPython is a tiny open source Python programming language. It is an interpreter language. Okay, okay, you just see here, MicroPython does not support entire Python standard library. So it is not supporting entire Python's, okay, supported. Okay, it is not supporting all the Python libraries. It is supporting only few libraries. Okay, you just remember that one. It is supporting only few libraries. Okay, if you want to okay, if you want to go for all the libraries, okay, then you shift to Raspberry Pi board and install Python into that particular thing. So then you can work. Okay, you can work with all the library files. Okay, so what is the advantage? What is the advantage? It is a small footprint. What is the advantage? It is a small footprint. Okay, nearer to hardware due to hard API. Okay, nearer to hardware means, what is the meaning of that one? Here no need to compile in Arduino IDE. After that, no need, okay, you don't need to dump. Directly you write a code. Okay, if you run, so automatically you will be getting, okay, output on your hardware kit. Okay, so those are the advantages. What is the disadvantage here? You are having limited libraries. You are having limited standard library functions for this particular, okay, you are having limited standard library functions for this particular, okay, MicroPython. So that is a drawback. Okay, that is a drawback of this particular, okay, that is a drawback of this particular MicroPython. So next one is, so features of this MicroPython is interactive, okay, so and all, so small footprint. Next, how you need to configure. Okay, configure means first you need to install the Python. After that, okay, you need to, okay, flash this particular Node MCU board with okay, you need to flash this Node MCU board with some firmware file. Okay, this is the file that you need to download, and after downloading you need to flash this particular Node MCU with this particular firmware file. After that you can run. Okay, this is the example code. I will show you practically this one. So what are all the different platforms that are available? Okay, so for this MicroPython coding, ESP Loader is one platform, one IDE. So where you can write this MicroPython code, okay, and you can connect your Node MCU board to your laptop, open your ESP Explorer. This is your ESP Explorer. But what is the thing means, disadvantage of this means, compulsorily you need to install Java here. Okay, compulsorily you need to install Java. You need to, download this ESP loader, and you need to download and install this particular Java. Okay, so that is the drawback. Now Thony MicroPython. Thony MicroPython is okay. So it is okay, very simple thing. So you can go to this particular HTTP this okay thony.org. You can go there directly. You can download the okay software. After downloading, directly you can connect your Node MCU board and you can do the programming thing. Okay. How to program this one? So that I will show you. Thony, how to where to download and how to program this particular Thony software and how to execute some output. I will show you practically. This is one platform. Next one is UPyCraft. UPyCraft is one more IDE which is also very simple thing for MicroPython and Node MCU based type of projects. Okay, so where you can all the required files. So Python where you can download. So you just see here python.org. From this python.org you can download the Python file. And sometimes what is happening means this micro power cable which is connected to your Node MCU board, sometimes in device managers it won't show that particular cable. If it is not showing, you need to install this driver file. You just see here, this is the driver file. You need to install this driver file first. Okay, if that is not showing in device manager, this particular MicroPython cable which you are connected, if it is not showing, compulsorily you need to install these drivers. Okay, if it is directly showing in your device manager, no need to install. Okay, if it is not showing, then you need to install this one. Okay, then only you can upload code into this particular MicroPython. And UPyCraft IDE, you can download this UPyCraft IDE from this particular website. UPyCraft IDE you can download from this particular website. And firmware, so compulsorily you need to flash your Node MCU with this firmware. So compulsorily you need to download this one. You need to download this one. Okay, after downloading this one, so whichever platform you are using, so in that platform you need to upload this one. So I will show you practically this one, all these things. So now I will move on to so I will be moving on to practical things. Okay, so I will show you practically how to do some things. Okay, so I will share Arduino IDE. 1 minute. All of you, can you see this particular Arduino IDE thing? All of you?
Yes, sir.
Okay, thank you very much. So now you just see here, as I told you, first what I have told. So in preferences, you just go to preferences. Whatever I have shown in PPTs, I will show you. In preferences, additional board manager is there, no? So there you need to copy the link. You just see here, that link is available here. I have copied already that link. Is it visible? Additional board manager.
Yes, sir. Yes, sir.
There you need to copy this link. After that, you need to click on OK. Okay. So now what you have to do? So you need to install boards. Okay. Suppose you just now what you have to do? You just go to tools. In that tools, go to board. In that, go to board manager. You just go to board manager. So go to board manager. So it will be opening like this. Now, instead of downloading this particular whatever board that is required, instead of downloading this particular board, from Google Chrome or some other thing. So what I can do, directly I can type that board name here Okay, initially you just see here it is showing downloading platforms index. So first it will download, it will take some few minutes. After that you can type your board name here. Okay, you can type your board name here and you can install that one. Okay, so wait for 1 minute. So once if it is completed, so I'll show you how to do it. So this is for now. You just see here now. Now that downloading platforms completed. Now what I have to do? So now I am working with Node MCU board. Node MCU board means what type of Wi-Fi module is available? ESP8266. Now what I can do? I can directly type Node MCU. So you just see here. If I am typing Node MCU, if I am typing Node MCU, directly it is showing ESP8266 module. ESP8266. Already it is installed in my laptop. So if it is not installed, what you have to do? So you just type Node MCU board and you just install this particular board. Okay. So if you are not installed initially, so it won't be available. This board won't be available in your thing. So already I have worked with Node MCU board. That's why I have installed this one. If it is not installed here, it will be showing like here you will be getting some install option. You just click on that install option. So automatically within 1 minute, so it will be installed. Okay. So like that you need to install the boards. Next, what is the other thing? You need to install the next, what is the other thing? You need to install the libraries. How to install those libraries? I will show you how to install those libraries. Wait a minute, it is okay. So just I have closed, it is taking some time. So now I need to install some libraries. So you just see here ESP Wi-Fi module library, or if you are using some sensor, that library if you want to install, like DTH, the temperature sensor library if you want to install, or some MQ135 fog sensor or air pollution sensor libraries if you want to install. How to install that libraries means, so you just see here, you just click on this sketch, include library, sketch, go to sketch, include library, and so manage libraries, include library and manage libraries. Go to sketch, include library and manage library. Okay, so it will take some 1 minute to open that library. After that it will take some time to add that library file. So wait a minute. How you are getting your board manager, how you are getting some pop up in the same way you will be getting here also. Okay, so it is taking more time. So wait a minute. So you just see here, library manager is opened. Okay, library manager is opened. So it is just updating the list. So now after updating, so what you have to do? So whatever library file that you want to install, you just click on that. Okay, you just type that name here and you can install that library file. Whatever link that I have copied in files preferences, if that link is not copied, so you won't be getting this facility. So directly you cannot download those library files directly. Okay, you cannot download all those library files directly. So first you need to go to file preferences So in that preferences, you need to copy that link. Whatever link that I have shown, you need to copy that link. After copying that link, okay, so you need to go to sketch, okay, include library. In that include library, you will be having manage library option, okay, manage library option. So if you are opening that manage library option, you will be getting this type of, okay, uh, window you will be getting. So now what it is showing, it is just updating the list of installed libraries. It is just updating. After completion of updating, now what you can do, you can type your required library file name. You can type your required library file name here, and you can type your required file library name here, and you can install that particular library. Okay, you can install that particular library. So it is taking few minutes. So I'm just closing it off. It is taking much time. Okay, so is that procedure is clear? How to install library files? Can anyone?
Yes, sir. Yes, sir. Clear,
Yes,
sir.
sir.
Okay, now you just see here. Now you need to, okay, type your library, whatever library that is required for you. So you need to type that library file name here. So Adafruit library. So I'm just typing Adafruit. So these libraries, it will take much time because so many library files are there. So even though I have typed that name, it is for coming that. So for showing that name, it is showing more time. It is taking more time. Okay. So procedure is this one. You can install. So next I will proceed with okay, experiments. I will proceed with experiments. I will just close this. Wait a minute. Okay. So now what I have done, so how to install boards and how to install libraries, so that I have shown. Now we will see different codes. So first this code is, okay, using web page, how to control different devices. Using web page, how to control different devices. Okay, I will show you this one. I will just dump this code into my Arduino board, Node MCU board. Okay, instead of showing my face, I will be showing kit now. I am connecting some external. Okay, so
నేను పొట్టిగా ఉంటాం మేము ముందు నుంచి ఉంటాం అంటాం
need to see whether now.
Now we can hear you, sir. Now you
Okay,
are-
I have connected that external this one camera. Because of that one, it is showing problem.
okay, okay, sir.
If I am connecting that external device, it is not taking audio.
Okay, sir.
Okay, I will show you using this one itself. Okay, now this is my device control using web page node MCU. Device control using web page and node MCU. Now, before dumping your code into your node MCU board, what you have to do is, so you need to select your board. Okay, this is my node MCU board. I have selected proper board. After that, you need to select the COM port. So whether if you are not selected proper COM port, so you won't get proper output. Okay, so I have connected proper board and proper this one. So now what I have to do, I need to, so if I click on this particular right tick mark, so it will just compile. If I click on this arrow mark, so what it will do means, so it will compile and it will upload your code into your into your Raspberry Pi board. Okay, this node MCU board. So now I am just clicking on this one. Okay, now you just observe here. Now you just observe here. Okay, it is just compiling. So compiling sketch. So now it is compiling the code. After compilation, it will upload that code into your node MCU board. So this is your node MCU board. I have connected that. So this is the kit that I have connected. Okay, this is the kit that I have connected. So it is compiling. After compilation, it will take few minutes. Suppose if I have not included this library file here, so or otherwise, so if that library file is not installed in your Arduino IDE, it will show error while compiling. It will show error here. Okay, so it will show error and it will show. So what is the library file that is required? So you need to install that library file. So how to sketch, include library manager. So you just go there and
తర్వాత వెళ్తావా ఒక 15 minutes పడుతుంది
so still it is compiling. It will take few minutes. So before that, I will show you what are all the things. So you just see here wired setup. So in this setup, what I have done initially, so GPIO pin 2 is my output pin. This is internal LED. So remaining all things are external LEDs. So pin 12, I have connected one external LED. Okay, pin 4 I have connected one external LED. Pin 5 I have connected one external LED. Okay, so I have connected 3 external LEDs and pin 2 is internal LED. Initially what I have done, I have kept all those things in low condition. Initially I have kept all those things in low condition, all the pins in low condition. Next, after that, what I am doing, I am just connecting all these things to Wi-Fi. Okay, I need to connect to Wi-Fi and I need to display that one in serial monitor. I need to connect. So whether it is connected to Wi-Fi or not, I need to display that one in serial monitor. So for that I have written code here. I will be forwarding these things also to organizers. From them you can get these codes. And after that what I have done, okay, so I'm just so you just see here, I have given some request HTML page. Okay, so if LED on is greater than 0, then automatically LED which is connected to this 12th pin will be in high condition. Okay, I am writing some HTML page here. So you just see here, this is HTML page. Okay, so after compilation, so it is taking some time. After compilation, I will show you, after uploading this code, I will show you how to see the output. So wait a minute. Meanwhile, if you have any doubt, you can ask. Meanwhile, while compiling and uploading, so it will take some 1 or 2 minutes. Meanwhile, if you have any doubt, you can ask. So this deep learning algorithms, all those things, okay, for those things from where you are getting huge data means from these IoT devices only you will be getting. Suppose you just take a smart city, okay, in that smart city what you are doing, so you are just monitoring all the all the street lights, okay, from one central location. You are keeping some LDR sensors, you are just monitoring the street lights whether they are in on condition or off condition. You are just sending this entire data to cloud. There you are analyzing. After analyzing, so if any device is in off condition, based on that one you can take necessary actions. Okay, so for deep learning, machine learning, for all those things, from where you are getting this particular data means huge data means, so from these IoT devices only you will be getting data. From these IoT devices only you will be getting data. So now compilation completed. Now it is showing uploading. So now it is showing uploading. While uploading, you can see this blue color LED, blue color inbuilt LED on your inbuilt LED on your Raspberry Node MCU board is blinking. While uploading, you can see inbuilt LED on your Raspberry Node MCU board is blinking. Okay, so now uploading is also completed. Okay, so now what you have to do, where you need to check this one. So now you just see here, if I open serial monitor, so it is showing some link. You just see here, it is showing some IP address. You copy this IP address, you paste this IP address here, you paste that IP address, okay, and click on that one. So I am just closing this particular code part. I will share one more like this web page so that you can see. Now is it clear? Is it visible, this particular thing? Client is connected. So and that IP address of that one is this one. Now you need to open this IP address. You need to open that IP address. I'm just sharing that I will just share that screen. So just wait a minute. Now can you see this one? Can you see this one web page? Can anyone please respond? Can you see this web page?
Yes, sir, we can see.
Now you just see here, if I turn on this light, wait a minute. So now what is happening? If I click on, okay, if I type that particular IP address here, so it is showing this particular web page. Okay. So if I type that IP address here, it is showing this web page. Okay. Now if we click on this particular, okay, light on or fan on, air condition on. So if you click on these things, so automatically corresponding light will be in on condition. Okay. So in this Microsoft Teams showing parallelly all these things, it is somewhat difficult. Okay. So if you click on this particular thing, and this IP address also, it is like net is somewhat slow. So if I click on that one, so here LED should be in on condition. So you just see here, if I click on that one, LED is becoming on. If I click on another one, blue LED is on. If I click on another one, red LED is coming to on condition. Now you just see here, if I click on turn off, so green LED is off. If I click on one more turn off, okay, one more is off. Okay, so if I click on this particular thing, so this internal LED will be coming to off condition. Okay, so net is somewhat slow. Now you just see here internal LED, blue color LED is also off. So like this, so you can control your devices. Okay, so here just I have connected. Okay, here just I have connected some LEDs. So you just see here green colored LED. So instead of collecting LED, what you can do here, you can connect some relay. Suppose if you want to switch on the AC, you connect relay and relay output is connected to AC. So if I click on this particular on button, so what it will do? It will switch on the relay. Once relay is coming to on condition, automatically your AC is also coming to on condition. If I click on turn off, so now you just see here it is coming to off condition. So like that, so like that using Node MC board, so you are writing a code and using web page, you are controlling all the devices. Using web, you are controlling all the devices. So for just simplicity purpose, so I am showing in online. So I am having this setup for real time thing also, but I cannot show that one in online. That's why what I am doing, I am just connecting LEDs. If I click on this one, so you just see here red LED is coming to on. If I click on this, turn off, red LED is coming to off condition. So if I click on this one, so you just see here internal LED is coming to on condition. Internal LED is coming to on condition. Is it clear? So like this, using Node MCU, you can control devices using your web page. Now, in a similar way, I will be showing one more thing, how to control devices. So I will share one more thing.
అసలు ఇంకెక్కకూడదు 1 బస్ నెంబర్ తీసుకుందాం అంతే. నేను ఈరోజు తీసుకుంటా 1 బస్ నెంబరు, ఎప్పుడైనా తీసుకుంటా. డ్రైవర్ని అడిగి వెళ్ళి సేవ్ చేసుకొని ఆయనకే ఫోన్ చేసి ఆయన బస్సు ఎక్కుదాం. మనం మామూలు ఇవ్వాలన్నా దసరా మామూలు ఏదైనా ఆయనకే ఇవ్వాలి.
Wait a minute, 1 minute.
ఇక్కడికే డైరెక్ట్ ఇంకా ఇక్కడే ఉంచుకొని ఇక్కడే కూర్చున్నాం. అలా ఇదిగో లాస్ట్ రోజు కొంచెం మనకు అక్కడ పోయి కనబడాలి తెలిసి వెళ్ళిన
So first I will show you this code, and after that I will show you this particular UB site. Okay, so this is the code. So here this is the 1 minute, I think my microphone is muted.
No, it's not muted, sir.
Okay. So this is the code for publishing my LDR sensor data in cloud platform. That cloud platform is UB dots. Cloud platform is UB dots. Okay. So in that cloud, I am publishing the data. So now what you have to do? So you need to write your Wi-Fi address, Wi-Fi username. You need to write your Wi-Fi password. Along with these two things, you need to write the token. So in UB dots, I have created one login. So if I log into that particular website, if I log into my account, so there it will be showing some token. I need to copy that token and I need to paste that token here. So if I paste this token only, then only this sensor data will be published in UB dots. This sensor data will be published in UB dots cloud platform. Okay, UB dots cloud platform. Now you just see here. Now I have connected this one. So I'll just reset this one. 1 minute. Once again I will dump this code. So I'm just dumping this code into my node MCU board. After dumping this code, so I will see, I will show you what is the data that is coming in serial monitoring, and what is the data that you are getting in UB dots website. Okay, so till now what we have seen, using some internet or using some app, how to control your device. So that we have seen. Okay, after that, now what you are doing, how to publish this particular data into cloud. Okay, how to publish our data into cloud. So that we will see now. After seeing this one, next we will see Tony platform. Okay, next we will see Tony platform and UPyCraft. So if time permits, I will show both. Otherwise, I will show one thing.
కొత్తగా వచ్చాడు.
So till now, whatever I am explaining, is it clear to you? Are you all able to follow? Can anyone please respond?
Yes, sir.
Okay, thank you very much. So wait for 1 minute. So for compilation and uploading, it will take some time. So after that, I will show you. In between, if you have any doubt, you can ask. So now you just see here. Now, so I have connected Node MCU board with LDR sensor. Node MCU board with LDR sensor. Okay, I am sending this LDR sensor data to cloud. I am sending this particular LDR sensor data to cloud. Okay. So where all you can use, okay, where all you can use, suppose you are having some trains or some other thing. So frequently some fire accidents are occurring. So you can keep this number of LDR sensors in those bogies, and you can collect all those LDR sensors data. Okay, based on that LDR sensor data, you can analyze, like it is like machine learning or okay, huge data you are getting. You are analyzing the data, and based on that analyzation, you will be knowing in which compartment actually fire has occurred. Or you can keep some, okay, LDR is a light sensing device. Okay, so or you can keep some these sensors, and you can analyze the data. So
Sir, can you suggest the analyzing algorithms actually at the time of that we to use for the LDR sensors? Because once we collected the data, we have to analyze the data where it is. So can you able to name it out some of the analyzing algorithms?
So I'll just tell you one thing. So for IoT devices, separate algorithms are not available. Separate algorithms, whatever deep learning algorithms or machine learning algorithms that are available, same algorithms you can do. But data which is required for that deep learning, all those things, you will be getting that data from these particular IoT devices. Separate for IoT devices, separate algorithms are not available. Is it clear, madam?
Sir.
Separately for IoT devices, there is no, you will be getting data. Based on this data, either you can use deep learning algorithms, or you can use some neural network algorithms, or you can use some machine learning algorithms. So already available algorithms you can use. Okay, separately for IoT devices, separately there is no specific algorithm. Okay, whatever data analyzing algorithms that you are using in deep learning, machine learning, all those things, same things you can use. Now uploading completed. Now you just see here, once uploading is completed, so now it is displaying the value of LDR sensor, light intensity value it is displaying. Okay, you just see here light intensity value it is displaying continuously in the serial monitor. Now I will just stop sharing this one, and I will show you in UB dots, okay, how to see this particular thing. Now can you see this particular UB dots?
Yes, sir.
So wait a minute, it is loading. So I have created the account. So after creating account, so if you go to this API credentials, okay, so these are the, okay, in that account you just go to API credentials. Okay, I am just clicking on that API credentials. Okay, once again I am just clicking. So now you just see here tokens. If you click on this, now initially token is not visible, but if you click on this one, token is visible. You just see here. Now you need to copy this token and you need to paste in the code. You need to copy this code and you need to paste this token in that particular code. Now you just see here all the sensor data, okay, sensor data in a graphical, okay, in a graphical way you are getting this sensor data. You just observe here, in a graphical way you are getting this sensor data, and you just observe here, you are getting this particular, okay, sensor data values also in this particular UB.Dots platform. Okay, sensor values are coming and graphical representation of that particular sensor data is also coming. Okay, suppose if I, okay, if I vary this particular, okay, I will flash some light. Sorry, ditla patukara. So if I flash some light on this particular LDR sensor, okay, if I flash some light on this particular LDR sensor, so you can see that values, so there is a reduction in that particular value. So if I click on that particular thing, refresh, now you can see the reduction in this particular value. Okay, 469 is coming. Once if I am removing that light, again it is coming back to 933. So like this you can publish your data in UB.Dots. Like this you can publish your data in UB.Dots. Okay, for that purpose also you can use your Node MCU board. Okay, is it clear? Is it clear, Node MCU board part? So now I'll just stop sharing this one. One more thing, using Tony platform, okay, using Tony platform, so that MicroPython thing I will show you. MicroPython thing I will show you using Tony. So wait a minute, I am just connecting the things. I'll just open Tony first, after that. So I'll just show you one last thing, Tony platform I will show you. After that we will wind it up. Okay, so MicroPython I will show you one thing. I thought of showing few more things, but
పోస్ట్పోన్ అయ్యి అంట కదా ఓఎస్ అండ్ జావా ఎగ్జామ్స్ ఆన్ 8 ఆర్ పోస్ట్పోన్ టు 11th.
one last thing I will show you, Tony.
మన ఫోటో వచ్చింది, స్టేటస్ పెట్టింది అమ్మాయి.
So this is your Tony platform. Okay, Tony platform. So similar way I have connected LDR sensor. Okay, so this is the code. So now what you have to do, you just go to tools, options, okay, and in that options you need to go to interpreter. So in that interpreter you just see here, you need to select the board. You need to select the board. Now I am using MicroPython ESP8266. I am using this board only, and you need to select the COM port. You need to select the COM port. You just select the COM port. After selecting that COM port, next thing is you need to upload the firmware. Okay, so firmware in the sense already I told you. So from some website you need to, so you need to browse this. So you just see here ESP8266 firmware. So you browse that firmware and you open that one. So now you just install it. You just install it. Okay, after installation completes, now what it is doing, it is erasing the flash, and after erasing the flash, so again it is installing that firmware. Okay, so you wait for 1 or 2 minutes. After that,
ఎంత క్యూట్గా పడ్డాము అందరం
once this uploading completes, then we can write the code and you can run it. Okay, first you need to upload these things. So where you have to go to tools. So in that tools options, okay, so tools options, okay, here tools options, in that options select interpreter. After that, whichever board you are using. Now I am using okay, node MCU board. In that node MCU, ESP8266 is inbuilt. Okay, ESP8266 board I am using. Suppose if you are using a different board, ESP32 board, you select that ESP32 board. Okay, and you need to select the COM port, to which COM port this particular node MC board is connected. After that, you need to, okay, upload this particular firmware. You need to upload the firmware. Once that is done, now you just click on OK. Now what you have to do, once that is done, you just click on stop button. First you need to click on stop button. Once if you click on this stop button, now you just see here, so at the down you are getting micro Python. Okay, so ESP8266 module you are getting. So now it is acting like a Python. If you want, you can check. So 1 plus 1, so it is giving. Okay, so I'm just typing a is equal to, okay, a is equal to some 3. Next type of, okay, so next I want to check type of this particular A. Okay, if I click, so what it is giving, it is integer. It is acting like a, okay, Python shell. It is acting like a Python shell. So it is acting just like our Python shell, but it won't support all the libraries. What is the difference between normal Python and this micro Python means it won't support all the library files. Okay, now we just click on this particular, again you just stop. So if you are just clicking on this particular stop, again you are getting that one. Now you just click on this run button. If you click on this run button, so you just see here that LDR value is displaying. I will show you. If you click on that one, that LDR value is displaying. Okay, and internal LED is also in on condition. That blue LED is also in on condition. Okay, if the intensity value is, okay, if the intensity value is less than 800. Now if I close this particular LED, okay, LDR sensor, now you just see here intensity value is 880. Now internal LED is off. Internal LED is blue LED on your Raspberry Pi board, node MC board is coming to off condition. Now if I open this one, okay, again you can observe LED is coming to on condition. Okay, is it clear? Is it clear to everyone? Now what is the difference between, okay, Tony, what is the difference between this Tony and what is the difference between normal Arduino IDE means? So Arduino IDE, what we have done, we have written the code and we have compiled. After compiling, it is uploading into node MCU board. But whereas in this Tony platform or UPI Craft platform, so you don't need to compile it. Directly you can run the code, automatically you will be getting output. Okay, directly you can run. Just like you just see here, I have written a code here. Okay, based on that code, it is displaying the value. Okay, light intensity value in the serial monitor. That values it is displaying, and based on that value, it is, okay, switching on your LED, internal LED. Now if I close this particular LDR, you just see here, now value is greater than 800. Now internal LED is coming to off condition. Now if I open that one, now you just observe here, your light intensity value is 300. Now what is happening? Internal LED on your node MCU board is coming to on condition. Internal LED on your node MCU board is coming to on condition. Is it clear to everyone? Is it clear to everyone? Excuse me, is it clear to everyone?
Yes, sir. Yeah. 100%.
Okay, thank you. So, madam, can I take 5 minutes extra?
Yeah, sir. Sure.
So I will show you that UPI craft also. With that I will close. Okay. So I will show you that UPI craft also, and with that I will see whether it is coming or not. If it is coming, I will take 5 minutes. Otherwise, I won't take. So I'm just stopping and I'm closing this Tony platform. So now I will just share this UPI craft thing. Okay. So this is UPI craft. So this is your UPI craft. So using this also, okay, using this also you can do the Python programming, MicroPython programming. So only thing is you just see here, go to tools, burn the firmware, okay, select the board. So you just select ESP8266, select the COM port, and after that, okay, select users, choose that binary file, firmware file. So you need to select that firmware file. Okay. So and after that, you just click. So now what it is doing? First it is erasing the flash. After that it is burning the flash. Once if it is erasing and burning, then you can connect and you can run. So then you will be getting output automatically. So these are very useful things. So all of you, please practice these things. So just 1 minute. So it will take 1 minute time. So after that I will show you output. Now you just, so it is okay, it is burning firmware onto your node MCU board is done. Now what you have to do is just click on this particular connect. This is connect. So if you are clicking on that connect, so you just see here these greater than symbols, 3 greater than symbols are coming. So what is the meaning of that 3 greater than symbols means? It is acting like a Python shell. It is acting like a Python shell. Now what you can do, so here in this particular thing you are having so many examples. So go to basic. I am just going with a blinking LED code. Okay. So this is blinking LED code. So now if I just click on this particular, so you just see here, if I click on this particular run button, download and run. So if I click on this one, now you can observe here LED is blinking. Are you all able to see this LED blinking? If I click on this stop button, so you just see here again LED stopped. If I click on this particular run button, again LED is blinking. Okay, stop means LED is stopping. So like this you can use your UPI craft, okay, for doing MicroPython code and dumping so directly you can run MicroPython code and you can see the output on your node MCU board. Okay. So with this I have done with my thing. So If you have any doubts, you can ask.
కాన్సీ లేదు గడ్డి ఉంటుంది అంత సీన్ ఎక్కడిది వెళ్ళడం బ్యాగ్ కూడా పడేయడం పడుకో
If you have anyone is having any doubt, you can ask. So no, IoT, all the IoT things are okay. All the IoT things are only thing is they are generating the data.
ఏదో ఒక
If you want to use some algorithms, okay, as usual, deep learning algorithms or machine learning algorithms, all those things you can apply on your IoT generated data. Okay, and healthcare means uh, healthcare means so you can have some body sensors like pulse sensing or some body sensors you can have, and that body sensor data is collected by using some cloud platform or some other thing, and that data is analyzed, okay, based on that one. So doctors can suggest some precautionary measures, okay, doctors can suggest some precautionary measures to the patients. Okay, so like that you can use your IoT platforms. Like you take your cell phone, so in this cell phone you are not having any weather sensor, but if you open that weather sensor app, you are getting that data. So from where you are getting that data? So that weather sensor app, okay, who are all are provided that weather sensor app in your okay phone, those people what they are doing, they are placing different okay sensors at different places. They are collecting all the data and they are analyzing that data, and they are giving that particular data to this particular app. Okay, like that you are, even though okay weather sensor is not available in our phone, you are getting weather data. How means? So all that sensor data is collected by that app provider, and he is analyzing that data. Based on that data he is giving the, so based on your location he is giving the okay temperature value. So in a similar way, anything. Okay, so some of they are asking my mail ID swekieae@gmail.com. So this is my mail ID. If anybody wants to interact with me, so you can interact using this mail ID. Any doubts? If no doubts, so organizers will mail these PPTs to you. So don't worry, we will share these PPTs to organizers. So mostly all of you, so see those links which are available in those PPTs. Okay, copy those links and you can try. Okay, I will forward these codes also to those organizers. Okay,
This much empty.
Madam Kavita Madam, I think no one is asking doubts. Can we close?
Yes, sir. Wait for a few seconds, sir.
Okay, ma'am.
Thank you, sir. Thank you, Dr. K. Tulsiram, sir. We are grateful for the time and effort you spent, and we express our appreciation on this wonderful session. Thank you from all the participants too. And the next session will be at 2 p.m. We'll have a half an hour break. Thank you.
Thank you, madam. Can I leave? So all the participants, I will be forwarding these PPTs, all those things to organizers. So they will be sharing all these details to you at the end of the this FDP program.
Yes, sir, sure. Yes, we are having afternoon session at 2 p.m. We'll take a break of half an hour and again join.
Thank you, madam. Thank you.
Thank you, sir.
ఇట్లానే ఉంచనా, స్క్రీన్ లాక్ చేయను, స్క్రీన్ లాక్ చేస్తా. అవును, ఈ పట్టిక అయిపోయింది కదా.